Everyone. I'm Indra from the School of Mathematical and Computational Sciences, Maths University. So today I'm gonna talk about Python, a language that has been shaping uh, PhD students' career. So let me start the slides. So this is my Twitter handle, IndraGhosh314, and like if any one of you is interested in following me, please do that. And let's delve into the topic today. So first, when I started out my career, from my high school, I directly moved to like a bachelor's in science in physics, and I had two options to either choose from maths or physics. I went for physics, and then like eventually when I started delving more into science and stuff, and of course maths, I discovered that I also love the computational aspect of it, and I needed a like a programming language to like simulate all the algorithms that I had in my hand that time. And what I discovered was C++ or like Java or JavaScript was not my thing. And then I discovered that it's Python, which really helped me to focus into the topic more and more. And as I moved into my master's in physics, I realized that this is something I wanna focus on more, where I get to do more computational stuff with like Python and like do more simulations. And and of course 2019 COVID hit, and I had to do something, and like my master study was interrupted, and then I completely took a detour and I moved to a data science company, like a startup, where I started using R. So the interesting thing is I didn't get much opportunities that time to like work in Python, but it didn't matter because like I got to work with another very interesting programming language, that's R. But I was like trying to hone up my skills in Python more and more during that time, and I also discovered that I loved the data science aspect of science. And but after that I also realized that I love doing research. And so I after as soon as I got my degree, I moved to a PhD position in applied maths, so which I'm really happy about, because I get to use Python almost every day of my life, where I try to simulate all the systems that I'm working on, and like create beautiful figures with Python, and of course Matplotlib, which is I'm gonna which is a topic I'm gonna like talk about more in the future slides. So that's the career trajectory. And the first memory that I have of using Python was learning it from a YouTube series, a tutorial series from MIT, which is a open courseware, and it was like the lectures were delivered by Professor John Gotag, which I'm pretty much sure most of you will know about. And it's a collection of like really interesting pedagogical Python tutorials, and which really helped me to realize more about Python and like realize the power that it holds. And I went through to be honest, I didn't finish the whole tutorial series, like watching the whole tutorial series, which is like I doubt many people do that, but I went through most of it, and I started using Python in working on physics programs, or mathematical programs. So this is the first time where I came across Python, and it really shaped my. I would say that this is the first time where I started shaping my career in terms of what I love to do. So, and then during my masters, I got this opportunity to attend this summer school, which is called Dynamics of Complex Systems, and where I came to learn some of the packages that I use now in my research. So one of them is SciPy. Uh, the other one is NumPy, of course, and the next one is NetworkX. And for like plotting stuffs, it's Matplotlib. And so I learned a lot of like not only Python stuffs, not only like programming stuffs, but also math stuffs. And this is the topic that I am working on my PhD right now. So interestingly, this is where this is the summer school where I met my current PhD supervisor, and we talked, and like somehow we both realized that this is what I would love to do for my PhD and shape my career in. So yeah, like that was really nice. And this was held in Bangalore, India, and I would recommend more students to like join from all over the world to this kind of summer schools where you can like potentially meet your future employers. Yes, so that's the fourth slide. So now more towards technical slides. So what's my job? So for my PhD, I work on switched dynamical systems. So to be to put it in a more popular term, it's like I work with systems which change over time. But interestingly, my time is so the system is not continuous in time, but discrete in time. And additionally, it has a switch like which can be thought of as abrupt events. So yeah, so that's my whole PhD project on, and I'm being funded by the Royal Society of New Zealand. And I would give my like shout out to Python, of course. Without Python, I would have never been able to apply my theorems, or like test my theorems or test my algorithms to see whether they are working fine or not. So yeah, so the two, like from my PhD project, the two papers that I published was these two, where I looked into the topology of chaotic attractors in of the system that we're talking about. And also like I, because I work in this system called chaos, I also proved this special chaos called robust Divini chaos in this particular system. So yeah, that's my PhD job. So I'm still working towards my towards the finishing of my thesis, and I'm hopefully I'm planning to submit by the end of this year. And the packages that I would love to give shout out to is are this Matplotlib, of course, for plotting beautiful plots, to create like to generate beautiful pictures, SciPy to do most of the scientific stuffs, NetworkX to like work on networks, NumPy to do numerical algebra stuffs and linear algebra stuffs, and pandas to like work on data and to to do data science stuffs, to do data analysis. Yeah, so these are some of the pictures that I have created using Python, and you can already see the prowess of Python, Matplotlib. Some toy projects that I have been working on over the years is this soccer data analysis. So with my colleagues from University of South Florida, University of Central Florida, we recently wrote a paper which is called a physics-driven study of dominant space in soccer, where we looked into this Voronoi diagrams, which applies to the dominant spaces of each player at a particular time on the field. So we are really proud of the project that we are working on right now, and of course it's Python with which we are like analyzing the data and coming up with new models. And the data that we used was from Metrica Sports sample data, and this is the GitHub page. This is the screenshot of the GitHub page that I'm referring to. Yeah. So I also have an introductory football data analysis blog where I have put resources, and like I have some um, like pages built in inside the blogs which teaches how to do data analysis in terms of soccer data, football data, using Python, of course. So yeah, this is a really, like, this is one of my favorite toy projects that I have been involved with the last few years. So if anyone is keen to help me out on this, please send me an email. This is the gallery. So really cool, really cool pictures. Again with Matplotlib and some of the packages like MPL Soccer that I've used to generate these figures. Cool stuff. The last topic, neurodynamics. So this is also a dynamical system topic, but more focused towards neurons and nervous systems. And again, we have written some papers on neurodynamics, and the core of all these simulations have again been Matplotlib, NetworkX, Python, SciPy, NumPy, Pandas. So yeah, that's it. So this is this particular system is like this is the visualization of the system that I'm talking about, which somehow exhibits the system, exhibits the behavior of the whole nervous system, where we have this central node and like connected by various peripheral nodes on the sides, connected by various links given by mu m and sigma n. Yeah, so and these are all the this is the time series plots depending on various parameter values. AC represents the entropy and so on. So everything could be done using Python. And finally, last but not least, so I also maintain a blog called Introduction to Mathematical Optimization, where I teach it's like a chapter-wise blog where I write or teach about numerical optimization using Python. And this is still a work in progress, so I would really appreciate any help from anyone who is interested in this topic. Yeah, so, and that's me teaching unconstrained numerical optimization in one of the first in-person PyCon that I have attended last year. That's Kiwi PyCon, and I'm based in New Zealand right now. So the PyCon here is really, really awesome with cool people who organize this. And I'm also looking forward to joining this year. And yeah, that's it. The photo credit goes to Christina, who took this beautiful picture of mine. And yeah, thank you. Any questions?